Okay, so last part of the integration chapter is where we've got to try and find areas that lie in between curves and lines and maybe the x-axis, y-axis. Not surprising, it's going to be the most challenging part of the chapter for us to have a go at, but as long as we sort of follow some basic guidelines, we should be all right. So we've got this area here which is bound between the curve of y equals x lots of 4 minus x and the straight line y equals x. And essentially with any question like this, sometimes it's too easy to try and like think about areas that are too big for what we're going to do. So at any point we've got here where the area starts or finishes, I'm going to draw in a vertical line going down those points, and basically I'm going to ignore anything that falls outside of that region. So I'm not interested in anything that's happening to the right or the left of that shaded area that I'm looking at. Now essentially how are we going to find this area? Well, I could find that area by finding the area underneath the curve between these 2 points as a whole thing, and then subtracting the area of this triangle made between this vertical line that I've put in and the line y equals x and the x-axis. So that's what we're going to have a go at. Now for this, let's just think about what information I need. Now I know that this passes through the point 0 here, so I've got that point, but I need to know this point on the x-axis because that's going to give me the upper limit for my definite integral. And how am I going to do that? Well, this comes from the point where these two equations meet, these two lines cross each other, so I need to do some simultaneous equations here. So I've got y equals x lots of 4 minus x and y equals x. So if I equate these to each other, and then solve, that's going to give me the value of x over here. So the first thing I'll do is expand this bracket. And then we've got a quadratic, so let's get everything over to one side, make it equal to 0. It's going to give me x squared minus 3x equals 0, and then we can factorize. This is nice and simple. So x is 0 or 3. Now we already know that they cross at 0 because they both cross the coordinate axis here at the origin. So this is now going to be the point 3. So I now have an x number. So I can do that for the area underneath the curve. What would I need for the area of this triangle? I'd need the base, which I've got, 0 to 3. I then need the height. Okay, so I now need to find this y-axis number here. So if I now say, well, if x is 3, y has to be 3 as well. Again, we already knew this one, but this is the one we're interested in. So now that gives me a value of y equals 3. So essentially what I'm going to do is find the area underneath the curve between 0 and 3, for which we have to integrate, and we're going to integrate the expanded expression. So 4x minus x squared with respect to x between 0 and 3, and then we're going to subtract from that the area of this triangle, which is base times height divided by 2. So when we integrate this, increase the power by 1, divide by the new power. And then we're going to subtract 4.5. And now what I'm going to do, I'm just going to use my calculator, plug in this original definite integral into my calculator and use that to find my answer. Remember though, for method marks, we need to see very, very minimum that you've integrated it correctly. And then after that, I probably would put the subtraction sums in there. I won't now just because I'm running out a bit of room. But if I set up my definite integral, I've got 4x minus x squared between 0 and 3. And that gives me 9. Take away 4.5. is 4.5. Top stuff.